I'm assuming was the one that you may have had some difficulties with. Number 5 said that you have two ordered pairs that pass through the parabola. And those ordered pairs were 4, 0, and 8, 0. It told you that those were x-intercepts of your parabola, and then the direction said to create two functions, one being positive, one being negative. There are at least 5 different ways that you could do this. There are an infinite number of solutions. So the equation, the possibilities are literally endless, as long as you have a mathematical explanation as to how you're finding your equation, not just by randomly plugging equations in the calculator and hitting graph. Brandon.
Can we use the midpoint formula to find the vertex?
Okay, so Brandon, what do you know about these 2 points with respect to a graph?
There are 2 points on a graph, and if we use the midpoint formula, we can find the vertex of the
Why?
Why?
Mm-hmm. Why can you use the midpoint formula? What are you really finding if you're saying we're using the midpoint formula?
The vertex.
Not the vertex.
The max or min value.
Not the max or min value.
A point on the graph.
No. What is the middle point between the two? What kind of graph do we have?
Oh, the axis.
Yeah, the axis of symmetry. So the axis of symmetry, if something's symmetrical, it means you have the same thing on either side. If they're x-intercepts and those x-intercepts are on your parabola, the axis of symmetry has to go through those two x-intercepts because those 2 points need to be symmetrical with any part of that axis of symmetry. So, yes, Brandon, you're using the midpoint formula. You're cutting that distance in half. And what number is in between there, Brandon?
6.
6. So that 6 represents the axis of symmetry, which is 6, or you could say that's also your h value. So now we know h. I'm going to just move this up so I can write underneath. Whoa. All right, so you are asked to come up with 2 equations, one that opens up and one that opens down. And I said there are infinite possibilities. So a vertex can be anywhere on the axis of symmetry. It could be closer up toward the x-axis. It could be farther down, away from the x-axis. The equation that we have been working with, I'm going to plug in that h because we now know h is 6, is that a times x minus h squared plus k. Our goal is to come up with one that's positive, and I'm going to make this negative because it said to come up with 2, one being positive, one being negative. What in the equation changes where the vertex would be located? How far down it goes, how far up it goes. Chelsea? The k value. So the k value tells us how far down the graph goes or how high up that value would go. We need to find k, but that k actually depends upon a, because a is the steepness of the graph. So if a is 2, that moves the k value down further. If it's 4, it moves it even down further. If it's 8 or 20, it moves it even down further. That number in front stretches the graph. So the larger number in front is actually affecting the k value as well. That number is up to you to choose, and that's why there could be infinite values. So you're going to pick that number to create an equation, because you can decide, do you want your k to go all the way down, or would you rather it just be pretty close, a standard parabola? The easiest number to pick for a is 1, because then you don't have any extra multiplying to do. So I'm going to make a be 1. And again, that's up to you to choose. Where do you want that vertex to be? How steep do you want your curve? That doesn't change the x-axis. Like the x-intercept, it doesn't change them at all. It just means that it's pulling the vertex down further, and it's going to make it a steeper graph. So I'm going to just make it a 1. What else can we plug into this equation? 4 for
The ordered pair
for x, and
8.
or
0.
a 0 for
Y.
y. So we can replace x with 4 because it's a point on the graph. we can replace y with 0. Or you could replace it with 8 and 0. What?
K equals 2.
K equals 2. Are you sure, Brandon? Oh, I missed my little square term here. That's
now
my
I'm
fault.
not sure.
So if you solve this, Brandon, 4 minus 6 squared is?
K would be negative 4.
There you go. So now K is negative 4. So if you look at the graph, it makes sense that K would be negative 4 if it opens up. If we change that A value to 2, then it would just take my K value and double it, and then it would become 8, or negative 8. And if we changed it to 3, then you'd be multiplying that value by 3, and now it's 12, or negative 12. So that A value just kind of moves the graph down. Alex?
So the way I did it, could you solve for A instead?
So you could solve for A instead. What equation did you use?
I used the same equation. I just picked 6, 4, and 6, negative 4, just because.
Just,
And solved it that
and
way.
then you still found A to be
1,
One.
and negative.
yes, sure. Other questions? So to get the other side, you'd still use 0. We would use a negative 1 here instead of a positive 1. You can still use a 4. But this is going to be negative 4 plus K, so now K is positive 4. Questions? That's just one way. There's multiple ways. Somebody used substitution and solved for the missing value using, well, I guess elimination, and solved for the value using elimination. So they set up 2 equations with both those ordered pairs, plugged in the ordered pairs, and used elimination. They're x-intercepts, so you can try and treat it as like an x-intercept and try and use both of those with intercept form that we talked about last year. So if you remembered intercept form from last year, that would be another way to solve. And I like this problem because it makes you think outside of the box. So the problems that we've been doing, you were given a vertex, you were given a point. What can you know about the vertex? What can you kind of remember about the axis of symmetry if you have these 2 x-intercepts? So it makes you kind of do a little application. Questions? So tomorrow you'll have a little quiz. That little quiz is just like the warm-up I gave you yesterday. So you have not this yet, but you might see that on an upcoming test. But there is the one parabola problem, like the first 2 on that review worksheet where you're working through getting standard form, getting the vertex, the axis of symmetry, the x and y intercepts. And then there's the other problem that is maybe 3 and 4 on that worksheet. It's on the bottom of the previous page, where you have a vertex, you have a point, and you're asked to find the equation. I have extra worksheets if you want to take one before you leave, just to go through and practice another problem. I really want everybody to get a 15 on 15 on this. So I have another problem. If you want to work through and practice it, feel free to grab one on your way out of class today. But it's exactly like what you saw yesterday. The quiz is like exactly like this, like same format. Any questions? So you'll have this like 10 minutes. Should take you 5, 6 minutes. Because you know what it is. No hidden secrets. Questions? So today we're going to work on talk about the calculator activity that I asked you to do. And I know there are multiple worksheets in there, and it's kind of confusing because there were so many worksheets that we were using yesterday. We did one in class. Does anybody have that worksheet that you didn't turn in from class yesterday that you're working with your partner? I'll take that. Yeah, I mean, if Kate's okay. Did Jenna turn it in? Okay. Anybody else not turn it in yesterday?
Did we have to give you ordered pairs, or did we just have to do like that?
Just a graph, no ordered pairs necessary. If you wrote words, words are good too. Yeah, words are good. So we're going to take the end behavior, the calculator lab, and we're going to try and use that today to summarize what the end behavior means. We're going to work on finding some pieces of polynomials today, which is just an extension of a quadratic function. Just polynomials, the big group. Quadratic function is a specific type. So in your notes, I think it's page 17. And then we'll kind of refer to the calculator at lab and kind of see, did you get that? What were you really looking at with that calculator lab, the end of behavior? So just a refresher from last week, the polynomial function has all those powers. So we did a n x to the power of n, a n minus 1, x n minus 1. Remember, that just means they descend in order. It doesn't mean it's there to confuse you. And then it ends with a1 x to the first, and then a sub 0. So polynomial function has whole number exponents. Brandon, can whole numbers be negative? No.
No.
Whole numbers start with 1 and they go on. So whole number exponents, and they descend in order. Descend, they go down with the largest power to the smallest power. That part is actually really important. Polynomial being in standard form has powers that are arranged in order. We're going to start dividing polynomials at the end of the week, and we'll have to make sure that our polynomial is in order from the largest to the smallest power. I'd rather do the dividing now, but we need to know a little bit about polynomials first before we can start dividing them. But it's something to look forward to at the end of the week. Dividing polynomials. So, characteristics. These graphs are smooth curves. If you remember back to last year, these were the graphs that had many humps and valleys. Sometimes they made a W. Those are the graphs that we did last year.
Isn't that x to the 4th?
It is x to the 4th, Brandon, nice job. And they are continuous, which means they go on forever, but they don't have any spot that breaks up the graph. So there's no spot where it can't be 0, or it can't be 5, or it can't be -3. So there's never an option where the domain goes from -infinity to 0 and 0 to infinity. The domain is always -infinity to positive infinity. So continuous means there are no breaks in the graph. So the domain for every single polynomial is always -infinity to positive infinity. Questions? All right, so we're going to start basic, and then we'll work with the last problem or two will be a little more involved. These two problems here might be similar to the ones that you did in the calculator activity. You probably just picked x squared, x cubed, x to the 4th. Did anybody pick a huge involved problem to plug in? No. So you probably had basic simple graphs. Every graph that's even, example y equals x squared, but y equals x to the 4th, y equals x to the 10th, y equals x to the 20th, any power that is even, the graph touches the x-axis at the x-intercept. So no matter what graph you had in your calculator activity, when you graphed it, it should have touched the x-axis at the x-intercept, but both pieces would end in the same way. It kind of touches it, bounces it, and if I'm looking at it from left to right, it was decreasing, touches the x-axis, becomes increasing. But it never goes through the x-axis, so that would be the difference. If it's odd, the odd graph crosses the x-axis and goes through it at the x-intercept. So every even graph, as long as it is just like x squared, x to the 4th, x to the 16th, it just touches the x-axis, kind of curves the other way. But the odd graphs will cross through the x-axis at the x-intercept and then continue on its merry way. So if it's increasing the whole time. It just swipes through the x-axis at the x-intercepts and continues on. So those are two things that you need to kind of associate with the power, and that's the goal. when you see a power, if it's x cubed, x to the 5th, x to the 7th, you need to have just like a general picture in your mind. What does it look like? So if it's even, you need to know they both do the same thing. They both go up, they both go down. And that was the goal of like that end behavior lab. So we're going to try and summarize that to make sure everybody's on the same page. So underneath, without using a calculator, we're just going to sketch these graphs. The thing we need to look at is the power, the largest power, and the value in front of that largest power. Is it positive or negative? So in this first one, it says y equals negative x to the 5th. Chelsea, what do you know about negatives in front of the x?
It'll flip it.
It'll flip it. So the negative here flips our graph over the x-axis. And that's from everything we've worked on so far this year when we've talked about graphs. A negative flips the graph. That was on your test, the last problem at the bottom of the first page. You do that part first. And then it says x to the 5th. Well, it's odd, so it has to cross through the x-axis. Since it's negative, this graph is going to start on the left and decrease to the right, crossing through the x-axis. So that's without me knowing anything else about the graph. I just know the power is odd and it's negative. So negative means it's going to decrease. Because it's odd, it goes through the x-axis. And then the second part says describe the end behavior. And this is the part where Alice said she just had words on hers, which is perfect because you're supposed to have words. The end behavior is literally where the graph ends. Generally, we focus on the inside because that's where you're finding the x-intercepts. That's where you're finding the y-intercepts. You're finding the vertex. But we actually need that end result to help us graph this as well. So when you're looking at the end behavior, last year we looked at the left and we described the left side. We looked at the right and we described the right side. So Alice, do you remember what you said on your calculator lab, like for the?
I think I said it enters through the second quadrant.
So it goes in the second quadrant. This one you would say would go.
Exits through.
Perfect. So she said it enters through the second, exits through the fourth, which is fine. Explanation is what's happening with the end. We can also say that the left side goes up and the right side goes down. That would be another way of looking at the end behavior. What's the left do? What's the right do? Well, the left goes up, the right goes down. That's an end behavior. So looking at letter B, we have x to the 4th plus 1. Brandon, what does that plus 1 do to the graph?
It just moves it up one.
It moves it up 1. And Brandon, if it's x to the 4th, what's going to happen?
It's a W.
It would be a w, but this is just a basic graph.
And it's just going to have y-axis symmetry.
Yeah, it's going to have y-axis symmetry. And actually, we're just going to make it, mine didn't touch. Okay, well yours is supposed to touch 1. Yours hopefully looks a little nicer than mine. Now, usually it touches the x-axis at the x-intercept. However, if we're shifting that value up, it's going to touch it at that value that it's shifting up to. But the key thing is to know that x to the 4th both end in the same area. Both of them are both pointed up. So you could say the left is going up and the right's going up. That would be the end behavior. And then this one, I think I have a typo on mine when I was typing it up. I believe you have x plus 4 to the 4th. So Michael, when it's x plus 4 in parentheses, what does that do to the graph?
You move it left forward.
Awesome. So left 4, it's still to the 4th, so the graph should still look similar to B, but it shifts to the left 4. Still both go up because it's even. So they have to do the same thing when it's even. So the left goes up and the right side goes up. So end behavior is where the graph ends. Questions? Did anybody get that on the calculator lab? Kind of? Yes, good? A little bit? So that's kind of what I was looking for you to get. If you had some kind of explanation, a graph, but the end is where literally the graph ends. Brandon?
I just put down it's a parabola that opens up,
That's perfect. Or if the parabola opens
down.
down. Yeah, that's fine. So what we're going to do in the bottom is a little summary so that you can use this as a reference for any power that's even versus any power that's odd. So any even degree would be x squared, x to the 4th, x to the 6th, and so on. And it doesn't just have to be a basic graph. This now goes for any graph. So you could have x to the 6th plus x to the 5th plus x to the 4th plus x to the 3rd plus 5. As long as the power, that original power, the first power is even, and the leading coefficient, that's the number in front. So if I have y equals 7x squared, as long as the number in front of that x squared is positive, then every graph ends in the same location when it has an even power. And I'm just going to draw the ending because they should both be going up no matter what that power. Positive number in front, even power. Now, instead of stating the left side goes up and the right side goes up, we're going to make it a little more algebraic. So it sounds like we're in pre-calculus, not in preschool. Which is fine being in preschool, but we're not there anymore, unfortunately. So on the left side, instead of saying we're on the left, we're going to say as x goes to negative infinity, because that means you're on the left side of the graph. So all the values that are on the left side of the graph, as x is getting closer and closer and closer to negative infinity, the y values we said were going up. That means they're going to positive infinity. So the left side of the graph, as x goes to negative infinity, y is going to positive infinity. It's going up. That's a mathematical way of stating it. And you're going to see that notation pretty much till you're done taking math classes.
Last year, did we just do L up and R up?
Correct.
We can't do that?
No. That's not very algebraic.
But we did it in algebra.
It's true. But now you're in pre-calculus.
But that's not
It's like,
algebra.
this is more grown up. It's grown up. You're growing up, Brendan. How many inches did you grow over the summer?
I don't know.
Okay, see? You're growing up. At least a couple, right?
I guess.
Yeah, sure. So as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, yes, that means you're on the right side, Brandon, but we're not going to say we're on the right. It goes to positive infinity. So if you could try and fill in the rest of the chart, knowing what you have from that calculator activity, I'm just going to make mine negative. So now I have y equals negative 7x squared. Draw yourself a little sketch. You're just worried about the end behavior. Since it's negative and it's even, they both go down. Positive even up, negative even down. And then I'm going to mimic my notation every single time. As x goes to negative infinity, now y is going down. Well, everything that goes down is negative infinity. So that little arrow means goes to approaches. We'll use that various times throughout the year, notation. And then talking about odd powers, so now we're cubed, maybe to the 5th or to the 7th. So you can make any equation that you want to use here. Just having something to kind of think about. So 3x cubed and negative 3x cubed. Draw yourself a little sketch of the end behavior and then write the notation. So positive means the graph should be increasing from left to right. So it starts at the bottom, it moves to the top. But a negative cube graph starts at the top, then moves to the bottom. So my goal is for you to be able to recognize a power and the number in front of that power and know what happens with the end behavior without relying on a calculator, just by looking at those two things. And that would go for any graph. Any questions with end behavior? So a good portion of your homework will be similar to this, and I'll show you two examples on the next page so you get a better idea of what your homework will look like. So it shouldn't be a lot of work. So tonight's math homework living might take 10 minutes. So that number might be a little lower if you were questioning for tomorrow. So if you look at the top example in the next page, this is similar to 2 homework problems, a handful of homework problems for tonight. It says use the leading coefficient test, which we also say is end behavior, to determine the left and the right, or the right and the left behavior of the graph of each polynomial. So leading coefficient is looking at the largest power and the number in front of it. So if we look at the first one, we have negative x cubed plus 4x. So looking at the largest power and the number in front of it. That largest power in this case is odd because it's a cube. The number in front is negative. So if you have this little chart out next to you tonight, you can look and find where it's odd and negative and then know what the end behavior should do. Because it doesn't matter how big and confusing the equation looks or how basic and simple it might be, it's going to end the same way. I don't want you to plug it in the calculator and get an actual graph of what it's supposed to look like. I just want you to focus on, because it's odd and negative, every graph that's odd and negative should end the same way. So odd and negative means starts on the left, falls to the right. Brandon.
As x goes to negative infinity, y goes to positive infinity. As x goes to infinity, y goes to negative infinity.
Good. And that's because odd and negative. There'll be other stuff going on in the middle. Right now we're worried about the end. So looking at the next one, going to the largest power and the number in front. That's what the leading coefficient test is. Find the largest power and the number in front. Even and positive, because there's just a 1 in front. So even and positive means they end up. Both end in the same direction. So both y's should be going to positive infinity on the left and on the right. Questions? So the other part of your homework, and like 3 or 4 problems of your homework, would be focusing on zeros. How many zeros a graph could have and how those curves are created. And Brandon said earlier that the graph that looks like the W was x to the 4th. Because the power of your polynomial should tell us how many answers we have. So that's what this little bubble in the middle is talking about. So depending on the power of n, we'd say we can have at most 4 zeros, or at most 3 zeros. So A would have 3 answers, 3 zeros. B should have 4 because it says x to the 4th. So the largest power tells you how many solutions there should be. And then underneath, it says it can have at most n minus 1 max or min values. Those are your curves. So I said these are smooth curves. You're going to have one less curve than you do solutions, because you have to be able to connect to those solutions, and when you connect those solutions, you're going to have one less max or min or one less curve. The other piece underneath talks about equivalent. Equivalent means what? Equal to, the same. So a 0 is a solution, could be written as a factor, and also an x-intercept. A 0 is an answer. It's an x-intercept, but we can write it as a factor. They mean the same thing. So a problem might say find an x-intercept, it might say find a 0. You're still finding the same information. So underneath, we haven't done this for a little while, it says find all real zeros of a polynomial, which means solve for x.
X equals 0.
Not x. Y. Y has to equal 0, Brandon, if we're solving for x, right? That's what you meant.
Yeah.
So if you're finding the zeros, you're finding x, you're solving for x, you're finding an x-intercept, whatever word you want to use, you need to let it equal 0.
Y
Now-
equals 0, then x can equal 0.
It could, but it can equal other things as well. How would you solve for x, Chelsea?
You take out an x squared.
You could take out an x squared, because Chelsea, what are you doing here to take out an x squared?
You're doing it so you can always.
So we're trying to break this down. so that we can find an answer using my favorite F word, factoring. We haven't done factoring in so long. It was like the first week of school. And in here, for us not to factor for 6 weeks, that's a long time. So then we have a negative 20. We'll do a lot of factoring. We just kind of haven't done it in a while. What two numbers make negative 20 that combine to be negative 1? Chelsea? Negative 5, positive 4. Because this is just a basic x squared. There's just a 1 in front. You don't have to go through that whole factor by grouping process. And then you're solving it, so now this is factored. I can solve it by taking each of these and setting it equal to 0. Which you all know, just kind of restating that. So one solution is negative 4, an x-intercept is negative 4, a 0 is negative 4. Just depends on how you want to phrase it. One answer is 5. And then the last one, technically, if you solve for x here, you're supposed to take a square root. Libby, every time we take a square root, really we have?
0 or
When you take a square root, what do you really have in front of that number?
what it is. Wait, no, I'm confusing myself.
Okay. Anyone help her? When you take a square root, what goes in front of the number every time you take a square root, Paris? Plus or minus. Do we write plus or minus 0?
That's a thing.
That's not a thing. But I told you there should be 4 x-intercepts, or at most 4 x-intercepts. And there really are 4 because that 0, there are really 2 of them there. We don't write plus or minus 0, but what we are going to write is something called a double root. A root is the same thing as saying a double 0. Tomorrow when we graph this, that's a special point on the graph. So there really are 2 zeros there, even though we're not writing it as a positive and a negative 0 to give us our 4 solutions. Questions? So I always wish I had like 10 extra minutes so that we could go through another problem completely. But again, you've got 3 problems, 4 problems tonight that you're factoring. Tomorrow we're going to focus on like finding all this stuff and trying to get it to graph.
So if there's really 2 zeros on the graph, then if you go down to 0, why do you something?
Oh, because you want, yeah, but they're plotted at the same point. It's not plotted at a different.
So it's for 0 for one half the graph and 0 for the other half the graph.
Sure.
Okay.
If you wanted the extra practice, it's up here. Feel free to grab one if you just want to work through another parabola problem to make yourself feel comfortable for tomorrow. It's on the desk. Feel free to grab it. Tonight's home.